All right, so like I said from before, I'm just continuing working with radical equations. I can just get straight into it since this is a continuation of before. If you have one radical equaling another, it's actually quite pleasant because as soon as you square both sides, you just have 3x equals 4x minus 1. That's pretty nice. And so I'm going to subtract 3x from both sides and add 1 to both sides. So I have 1 equals x, and I'm done. Well, sorry, I should check. And take this 1, put it in here, and put it in here, and it'll work. You get the same, you get root 3 on both sides. Perfect. Well, that was a nice way to start. Again, if you just have one radical equaling another radical on the other side, and they're both the same type of root, yeah, just it comes together quite nicely. This will not come together quite this nicely. But we can, well, the one thing I don't recommend doing right away is squaring both sides. You could square both sides right away, but you'll make it needlessly messy on yourself because I don't really need to have a 5 and a 7 over here. I can get rid of one of them quite nicely. I always generally recommend getting rid of this, if we have terms on both sides, getting rid of the smaller one, so I'll subtract 5 from both sides. So then I have 2 plus the square root of 3x equals the square root of 5x plus 4. A little bit simpler than before. Now I really have no choice. I got to square both sides. So the right-hand side is quite nice. Just 5x plus 4. The left-hand side is a binomial, right? I have one term plus another, all squared. It's kind of a weird binomial because I have that root 3x in there. But it's, you know, I can build upon things we've done with polynomials before. I know there's going to be 3 terms here. I know the first term is going to be 2 times itself, so 4. I know the last term is going to be root 3x times itself, so 3x. The middle term is going to be 2 times root 3x times 2. So 2 times root 3x is 2 root 3x times 2 is 4 root 3x. Alternatively, I could write it out twice and I could FOIL it out. But again, I'm hoping we can go from here to here as quickly as I just did. Because again, it's building on things we've done well before this lesson. Now, I still have an x inside a radical. Okay, I still have root x I can see right here inside a radical. That's it. Let me clean some stuff up first. For example, I subtract 4 from both sides. Both those are gone. And I also have x's on both sides. I'm going to get rid of one of them. I'm going to subtract 3x from both sides. So now it's cleaned up a bit. I have 4 times root 3x on one side and just 2x on the other. Okay, that's a lot nicer. So what do I do now? I have a few options, but I'm just going to square both sides again right now. Because again, I still have a radical. So on the right-hand side, I have 2x times 2x, which is 4x squared. On the left-hand side, I have 4 times itself, so I have 16 times root 3x times itself, so just 3x. Right, 4 times 4 is 6. Root 3x times root 3x is just 3x. Okay, now it's getting much nicer. Now I have 16 times 3x, which is 48x on one side and 4x squared on the other. How do I solve this? Again, I have the makings of a quadratic equation. So let's bring everything to one side. I'm going to subtract 48x from both sides. So this equals 0, and I have 4x squared minus 48x on this side, which I can solve quite nicely if I can factor this. How do I factor this? Look for a greatest common factor, and the greatest common factor is 4x. Take out a factor of 4x, and I have just x minus 12 left. And now I can inspect my factors to find the solutions. One of them I can see, it looks like it's going to be x equals 12, although I have to check. When x equals 12, that factor equals 0. Once that factor equals 0, everything on the right-hand side equals 0. Also, right here, x can equal 0. If that x equals 0, I have 4 times 0, which is 0, and 0 times anything else is 0, which is what we're trying to get to. We're trying to equal 0. So it looks like I have 2 solutions, but now we just got to go back to the original equation, go back here and check. Replace your x with 0, and that'll work. Replace your x with 12, and that'll also work. So again, I don't think at this point you need to watch me substitute all those in, but both work. So I will say make sure you check, but both work. Okay, so I'll just kind of make the comment here. Both work, and so therefore x equals 0 and 12. And again, as soon as I got to this step, I saw we again had the makings of a quadratic equation, which means we have this x squared term. And so again, trying to make everything equal 0, factor, and this has been happening more and more. And this will become the focus of the next unit. And this is the last lesson in this unit. So we don't want to shy away from questions where we're using factoring to solve these quadratic equations. It really will help us a lot in the next unit, which has become the focus of it. All right, is this the last one? Yeah, last one for a rather short final problem. And so here, this is about as messy as it gets in terms of solving radical equations for this course. And so right now, I could subtract 1 from both sides, but it doesn't really do me any good. So I'm just right now going to square both sides. The left side is fairly nice. It's just 2x plus 3. The right side, again, I have this binomial with a radical in it, but it's not that bad. It's going to be a trinomial, 3 terms. My first term is going to be 1 squared, which is 1. My last term is going to be root x plus 1 squared, which is just x plus 1. And my middle term is going to be 1 times root x plus 1 times 2. So 2 root x plus 1. All right, so let's clean some things up. Do this in a few steps. For example, I'll do a few steps. 2x plus 3 over here. On the right-hand side, I have 2 root x plus 1 plus x plus 2. So I got x's on both sides. I have a constant on both sides. Let's subtract an x from both sides. And let's subtract 2 from both sides. If I do that, I have just x plus 1 on one side. And the other side, I just have 2 times root x plus 1. All right, so considerably better than what we started with. Well, actually, a bit better than we started with. Considerably better than it was a few steps ago. But at this point, we got to square both sides again. The left-hand side, again, I have this binomial squared. So it's going to be x squared plus 1.
Just a reminder of the health and safety meeting on Teams at 2 o'clock in the general channel. See you then. Thank you.
I'm sure you're glad you heard that. So again, x plus 1 squared is x squared for the first term, 1 squared, or 1 for the last term, and then x times 1 times 2 for the middle term. The other side, I have 2 times root x plus 1. Well, 2 squared is 4, and then root x times itself is just root x plus 1 times itself is x plus 1. And now all my radicals are gone, so I have x squared plus 2x plus 1 equals 4x plus 4 when I distribute that. Again, I have the makings of a quadratic equation. Again, I want to make everything equal to 0. So let's subtract 4x from both sides. Subtract 4 from both sides. I want to keep my x squared term positive. It'll make it easier to factor. So I have x squared minus 2x minus 3 equals 0.
Bruschetta is ready. Please come to the NLC window between 1:50 to 2 o'clock and 2:30 to 2:50 today to pick it up. Again, a reminder to all staff, your first firebox, bruschetta is ready. Please come to the NLC window between 1:50 and 2 o'clock and 2:30 to 2:50 to pick it up. Thank you.
Those announcements are probably more interesting than this video, so hope you enjoyed those little distractions. That's it. I factor x squared minus 2x minus 3, and that factors into x minus 3 and x minus 1, so x plus 1. Inspect my factors. One of my solutions seems to be x equals 3. One of my solutions seems to be x equals negative 1. I say seems because I have to check, but when you check, both work, which means I have 2 solutions. X equals 3 and negative 1. And that is as complex, and there's a lot going on here. This is as complex as solving an equation gets in this unit. And probably the whole course. I mean, there's a lot of algebraic work there compared to previous ones. So this is like as much as it gets. Most of them are not nearly this much. Like compare that to the first question. That's a pretty big difference. All right, final problem. Without solving, which of these do I know will have no solutions? How can I tell? So for this, I would highly recommend you kind of pause the video and just try it on your own. And there's nothing wrong. I mean, I could just solve for each of these variables. But I can tell sooner than that which of these will have no solutions. So I'll mention that in a moment, although I do encourage you to try it first. And so let me quickly mention my solution before another announcement comes on. For example, here, if I just add 2 to both sides, I see I have root 3y minus 1 equals 7. There must be a possibility. There must be a way that this is going to work. There has to be some number that when I eventually square root the left-hand side, I get 7. Okay, there's got to be a way there's going to be a solution there. I could now figure out what it is, but there's no reason. There's got to be some number that when I multiply by 3, subtract 1, square root, it'll equal 7. There's no reason that should just be impossible. But one of these will be impossible. Let's look at this one. Here, I want to subtract 4 from both sides. So I have minus root m plus 6 equals negative 13. Now I have a lot of negatives going on here, but one thing you could do is I could just swap around these 2 terms. I could bring that term over here, bring that term over here. If that makes it look nicer, I get 13 equals the square root of m plus 6. But again, I don't know what m is. I'm not going to figure out what m is, but I know it must be possible. There must be some number that when I add 6 and square root, I get 13. So what would lead to something that is impossible? Well, that's like this solution, right? This one right here. If I subtract 9 from both sides, I get the square root of x plus 8 equals negative 7. And right here we have a problem. Because I don't care what number x is, or I don't care what real number x is. If I add 8 and then square root, I'm never going to get a negative out. Right? The square root of any number you pick will always come out to be, you'll never get a negative out. As long as you put a real number into here, you're never going to get a negative number out of here. And so as soon as I'm solving an equation with a radical, and as soon as I see a radical is going to equal a negative number, there's no point me even going on. I know this can't work. Again, the square root of if pick a number, find the square root of it, it's going to equal at the very least 0, if not more. If you're picking a real number and you find the square root of it, you'll never get a negative out. So as soon as I reach this point, I know there's no point going on. This must have no solutions, just this one. You could algebraically solve it. You'll get a fake solution, but then when you check, it won't work. And with that said, and before another announcement comes on, that finishes this lesson and this unit.